Today what we're going to look at is our final method for solving quadratics. So we are going to look at the quadratic formula, and our answer can either be as a fraction, maybe an integer, or it's going to keep in that radical form. So we'll just have to figure out based on what we've got. So again, our four methods. Graphing is one where you're looking for your x-intercepts. 2 is factoring. 3 was completing the square, which is what we did last block. And then 4, which is what we're doing today, is a quadratic formula, and this will always work. So that's something exciting to look forward to. So when we solve a quadratic equation by graphing, you've got 3 different graphs that could happen. Your first one is that you have 2 solutions, and so that's crossing the x-axis in 2 places. Next, you could have 1 repeated solution because this answer is actually happening twice, like I'm getting an x equals 1 and another one, it's the same number. And then here, this would be no real solution because there are no x-intercepts here. And this is where we're going to be looking at imaginary solutions. So let's get started. When we talk about the quadratic formula, I wrote a couple things here. You are going to have to know this from memory. So this is going to be something that you're going to have to memorize, and it is going to yield 2 different answers because there is a plus or minus. But most importantly, you need to know this information. It has to be in standard form. If it's not in this standard form, then we cannot use the quadratic formula. So make sure you always have it in standard form prior to putting it in the quadratic formula. So here are some steps. First, put it in standard form. Make sure it looks like ax squared plus bx plus c and it equals 0. That piece is really important. Write down your a, b, and c. Then you plug them in, and then we're going to simplify in pieces with our calculator. Then we're going to make sure that we write both our answers as 2 separate numbers. So without further ado, let's get started on a quadratic formula. So I'm going to look at this and think I need to first put this in standard form. So I'm going to add 1 to both sides. So this will give me 5x squared plus 8x minus 4, and this should equal 0. So I've now put it in standard form. What I'm going to do now is I'm going to separate what's my a term, what's my b term, and what's my c term. If you remember, the a term is simply the number, so this would be 5. My b term is simply the number, this is 8. And I get that from here. And the c term is just a negative 4. So now what I want to do is I want to plug this information into the quadratic formula. So I remember it's negative b plus or minus the square root of b squared minus 4ac. And this is all over 2a. So what I'm going to do is I'm going to plug in my information. So instead of writing b, I'm going to say negative 8 plus or minus the square root. And then I'm going to put 8 in parentheses, and that's really important, minus 4 times my a term 5 times my c term negative 4. I'll have to extend my radical a little bit. All divided by 2 times that a term, or 5. And so from here, what I'm going to do is I'm going to first plug in what's underneath the radical. So I'm going to plug this into my calculator with no radical. So what I'm going to do is I'm going to say, okay, parentheses, 8 close parentheses squared minus 4 times 5 times negative 4. And that's going to give me 144. So I'm going to say this is negative 8 plus or minus the square root of 144 divided by, and I know 2 times 5 is 10. I'm almost done at this point. What I should do is I should check, is this a perfect square? If the answer is yes, then simplify. So in this situation, 144, I can take the square root of 144, and this equals a plus or minus 12. So what I can say is this is negative 8 plus or minus 12 divided by 10. Then I need to write my answer as 2 separate answers, so negative 8 plus 12, divided by 10, and x equals negative 8 minus 12 divided by 10. And then I'm going to go ahead and simplify this one step further and say, well, negative 8 plus 12 will give me 4. This is x equals 4 divided by 10. And I know that simplifies to be 2/5. And then this one would give me x is equal to negative 20 divided by 10. and this gives me x equals -2. So at this stage, I'm done. These are my answers. So hopefully you feel like, hey, this quadratic formula is a lot more straightforward than maybe some of my other methods. And this one will always work. So what I want you to do is I want you to go ahead and pause the video and see if you can solve the other equations on that piece of paper. And I will roll through these and you can check them in a minute. So go ahead and pause the video and see if you can solve these next problems. So I hope that you have made an attempt to solve these on your own. Whoops. And so first, what I'm going to do is I'm going to go ahead and put this in standard form. So this is going to give me a 2k squared. There was no like term of this negative 2k on the other side, and this is going to give me a -20, and that should equal 0. So at this stage, what I'm going to do is I'm going to plug this into the quadratic formula. So I'm going to make sure I know what my a term is. It's 2, my b term, which is -2, and my c term, which is -20. You can take out a GCF out of all of these, but that kind of makes my problem more complicated, so I'm just going to leave it in. Then I'm going to plug it into my equation. -b plus or minus the square root of b squared minus 4ac all over 2a. So now I've got a negative, and my b is negative. So this -2, it becomes a plus or minus, and then I need to put parentheses around this -2 squared minus 4 times my a term of 2 times my c term of -20. And I'm going to divide this whole thing by 2 times my a term, or 2. Again, I'm going to plug this into my calculator, and I'm going to make sure that I put this in parentheses appropriately. So I'm going to say -2 squared minus 4 times 2 times -20. And that's going to give me a 1/64. So this -2 on the outside here becomes a +2, plus or minus the square root, and this is now 1/64 divided by 4. I'm going to check and see if 1/64 has a perfect square. Is this a perfect square? And the answer is no. So what I'm going to do is I'm going to leave this as my answer. So I'm going to say x is equal to 2 plus the square root of 1/64 divided by 4, and 2 minus the square root of 1/64 divided by 4. And I cannot cancel these 2's and 4's together. That is not possible, so go ahead and leave your answer like this. My next problem, I'm going to do the same thing. So I'm going to subtract my 6x. I want this to be in standard form. I'm going to add 3. This is going to give me 3x squared, and this is going to give me plus 3x plus 11 is equal to 0. And I'm going to plug it into my quadratic formula, but I'm first going to say what's a? It's 3. What's b? It's also 3. And what's c? It's 11. And then I'm going to plug this in. -b plus or minus the square root of b squared minus 4ac all over 2a. And I'm going to say, all right, -b becomes -3 plus or minus the square root 3 squared minus 4 times 3 times 11 all over 2 times 3. This is going to give me -3 plus or minus, and I'm going to plug this into my calculator and figure out what that gives me. So this gives me 3 squared minus 4 times 3 times 11. And this is going to give me a -123 divided by 6. I'm going to check and see if this is a perfect square. And I'm going to figure out no, and actually I get an error in my calculator. So when this happens, when I get a negative under my square root, I'm actually going to call this a no real solution in this situation. My graph, if I were to graph this standard form, it's going to look something like, and now I don't remember my a term. My a term is positive. It's going to look something like this. There are no x-intercepts that are real. So what I want you to do at this stage is you've got time to practice. So what I want you to do is find a partner and sit next to them And then what you're going to do is you're going to work on this piece of paper and you're going to fill it in appropriately.